morning, one and all. My name is Sudhakar. I am going to teach about the basic manufacturing technology. In that, we are discussing about the lathe and lathe machine operations. Before starting today's class, you can recall yesterday's class. The previous class, we have learned the lathe operations, right? They are turning operation, facing operation, step turning operation, taper turning operation, eccentric turning operation, including that drilling operation, reaming operation, boring operation, threading operation, parting of operation, keyway cutting operation. So these are all operations I have learned so far till yesterday, right? So these are the operations performed on the lathe machine. So for doing drilling operation, we are using the drill bit, and it will be fixed in the tailstock. Reamer also fixed in the tailstock. Boring tool also fixed in the tailstock. For doing thread cutting operation, we are using offload mechanism. Parting of operation means we are removing the material, which is the we are removing the finished material from the bar stock. Keyway cutting, it is used to provide the slots on the cylindrical parts. Okay, so these are the operations we have learned so far. Now today we are going to discussing about the taper turning methods. Right? In the taper turning method, we are having different types of methods. We know what is taper turning, right? So taper turning means to produce the conical surfaces on the workpiece. That process is called taper turning. We know that the taper turn for producing tapers, we need some inclination angles, right? So because of that angle, we are producing the taper shape. In the first introduction level, we are learned that for producing cylindrical surface, the cutting tool is moving parallel to the workpiece axis. And producing the flat faces, we are the cutting tool is moving perpendicular to the workpiece. For inclination purpose, for producing taper shapes, we are fixing our cutting tool in inclination to the workpiece axis. Taper means the diameter may be gradually increasing or decreasing from one end to another end. The diameter increasing or decreasing gradually from one end to another end. That shape is called taper shape, right? For doing taper shapes, we are having different types of methods. That methods are going to discussing about this lesson. Okay. So on completion of this period, we would understand that what is the compound rest swelling method and how to calculate the angle. We need the angle for producing the taper shapes. And that taper turning by taper attachment method. Right? So before going to discussing about the processes, once again we can recall that what is taper turning. Taper turning means it is a conical surface produced on a lathe is called taper turning. To do this operation, to do this process, we are moving our cutting tool at an angle to the axis of rotation. The angle of we are fixing our cutting tool some angle to the axis of the workpiece, right? To produce the conical surface is called taper turning, and for doing this, we have to fix our cutting tool at some inclination angle to the workpiece. So some of the methods for taper turning. The first one is forming tool method. Second one, compound rest method. Third one, taper attachment method. And the fourth one is tailstock set over method. So by these four methods, we are producing the taper shapes on the workpieces. Right? The first one is forming tool method. Second one compound rest method. Third one paper attachment method. And fourth one tail stop set over method. So in the coming next slides, we are going to discussing about these four processes in detail. So before going to discussing about that, what is taper turning? It is a conical surface producing on the workpiece, right? So we are going to discussing about the taper turning by forming tool method, right? The name itself tells that form tool, right? So what are the shape? What are the shape or what are the taper we are producing on the we are going to produce on the workpiece? The same and similar to opposite that face is on our cutting tool, right? Forming tool method means we are not doing any inclination angle here, any calculation here. Just we are how much angle we are going to make on the workpiece, how much taper we are going to produce on the workpiece. So that much angle we are producing on our cutting tool also, right? So the similar shape cutting tool we are using in forming tool method, right? So here is the first point. We know the tool has a cutting edge inclined at the desired angle with the axis of rotation. The tool has a cutting edge. How the cutting edge looks like? It is inclined at the desired angle. It is also some inclined shape with the desired angle. What are the angle we need? That shape, that angle, the cutting edge of the cutting tool is formed. So that is with the axis of rotation of the workpiece. So with that desired angle cutting edge, we are producing the taper shapes. How much angle? That angle should be is equal to half the taper angle. The angle is equal to half of the taper angle, and the tool is fed straight into the workpiece. Only short tapers can easily be turned, right? So in a simple way, we are discussing this taper turning by forming tool method. In this, the workpiece is fixed in the chuck and it is rotating, right? And we are not give any angle on the compound rest. Just you have to make your tool, right? You have to make your tool with how with some angle, with some desired angle. What is the desired angle? That angle is produced on that angle is produced on the workpiece. So with that tool only we are getting the desired taper shape, right? So with that cutting tool only we are getting the desired shape. So with that shape we are producing the taper on the workpiece, right? So here the main thing is we have to make the tool with inclination angle. What are the desired angle we need? What are the desired angle? That angle is equal to half the taper angle, right? Why we are again telling that half the taper angle means, right? In the earlier classes we have discussed that if we want to give depth of cut, how much depth of cut we have to give, right? So if we want to remove 2 mm material, how much depth of cut we are giving? Only 1 mm because the workpiece is rotating in the chuck. For that reason, we are giving the half of that desired, half of that depth of, half of that removal of diameter. Right here also, the workpiece is rotating. That's why we are taking that the angle is equal to the half of the taper angle. Right? So directly we are fed straight into the workpiece. The tool is fed straight into the workpiece. So after fed on the workpiece, what are the shape? What are the shape on the cutting tool is produced on the workpiece also, because the cutting tool is made by angle. What are the desired angle we need, right? So what are the desired angle we need? The cutting tool is shape. So after that shaped cutting tool, we are directly fed our cutting tool onto the workpiece, right? So by that we are the workpiece also having the same shape. The workpiece is also having the same shape which is having on the cutting tool, right? So the cutting tool is having some length, right? Some width, sorry. It is having some width. With that width, we are having the inclination, right? We are having that inclination. Only that much taper are produced on the workpiece. Understood? The cutting tool is having some width, right? How much width we are we have to manufacture before producing the shape. The cutting tool is having some width, but that width it is having inclination. In that width it is having inclination. So after fed onto the workpiece, it is having the workpiece is having that much taper only, that much length of taper only, right? So that's why only short tapers can easily be turned. Only short tapers can easily be turned by this taper turning. So here, this is our workpiece, right? And the cutting tool is here. The shape of the cutting tool is similar to this shape of this workpiece. Shape of the cutting tool is to how much paper we are producing in our piece, right? So we are directly fed our workpiece, our cutting tool onto this workpiece. It is having some length, that much length only, that much width only we are producing the paper, right? On the top view, we are observing that paper turning by compound rest method. So this is also paper turning principle by compound rest method. Okay. So before going to discussing about the compound rest method, just we are again recall that forming tool method. In this forming tool, because the tool is having the inclination. What is that inclination? That is the desired taper shape on the workpiece, right? With that desired shape with that desired shape, that inclination is having on the cutting tool. With that cutting tool, we are directly fed onto the workpiece. So by doing so, we are having same shape on the workpiece, right? This is the forming tool method. Now we are moving to the compound rest method. Before going to discussion about the compound rest method, just observe this figure. So it is our workpiece, right? So we are giving feeding in this direction. We are giving feeding in this direction. That means this is the workpiece axis and it is the cutting tool axis. For extending this meets somewhere here. So these both are having some inclination, right? So both are having some inclination. So this is the basic principle for producing the taper shapes on the workpiece, right? To produce the taper shapes on the workpiece, the cutting tool is having some desired inclination. With that desired inclination, we are moving our cutting tool onto this workpiece. With that movement, we are getting the taper shape on the workpiece, right? by top view, we are observing the method of the compound rest method, swivelling compound rest method. This is our compound rest. Here we are fixing our cutting tool with some inclination. After giving depth of cut from here, we are rotating this wheel to the movement of the cutting tool. In the lateral discussions, the before discussions, we are rotating this wheel for giving the feed to this compound rest. But in the compound rest swivel method, we are moving this wheel to moving the cutting tool, producing the taper shapes. Right? So this is the second method. The first one is form tool method. In the form tool method, the tool is having same shape of the workpiece, which is producing the tapers on the workpiece, the desired shape on the workpiece. Now the second method is compound rest method. It is used for turning longer tapers than produced by a form tool. The taper turning by compound rest method, it is used for turning longer tapers than produced by a form tool. Already I have told that the drawback of form tool method, the cutting tool is having some width with that width only, with that width shape only, it is reproducing on the workpiece. So that much of width is only on the that much of width is produced on the workpiece. So we are getting that much of taper shape only. So it is used for only short length tapers. If you want to produce longer taper shapes, long taper shapes, we are going to another methods. In that, one of the method is compound rest method. By doing compound rest method, it is used for longer tapers than produced by a form tool. The length of taper is limited to compound rest slide movement. Here, another drawback. Here in this turning compound rest method, we are having one drawback. That is, in that forming tool method, the length is limited to the width of the cutting tool. The length of the taper is limited to the width of the cutting tool. Here, the length of the taper is limited to compound rest slide movement. Compound rest slide movement. That means here we are giving feed by this wheel by rotating of this wheel. By rotating the of this wheel, it is moving some distance up to here. Up to here only it is moving. So up to here it is moving. That much of length of taper is produced on the workpiece. Understood? We are rotating this wheel. So it is moving by inclination angle on the cross line on the compound rest. So that much of length only up to here it is moving. So that much of length of taper is only produced on the workpiece. Okay. So that's why here the drawback is the length of taper is limited to compound rest slide movement. So now the next point is here we need the angle, right? Cutting tool is we are not having the inclination cutting tool. We are having the general cutting tool, right? But we need some inclination angle here, right? For that inclination angle, for that required angle, uh, we need for that required angle, we need some data. So for that reason, the compound rest is graduated with degrees, right? The compound rest is graduated with degrees, right? So on that compound rest, it can be swiveled to a desired angle. Understood? Here we need some inclination angle. So that angles are graduated on the compound rest, right? That so we can swivel to a desired angle. Hence, we will do a desired angle. Compound rest is graduated with degrees and it can be swiveled to a desired angle, right? How much angle we have to swivel? That is the main point. Here we are having the inclination angles on the compound rest. Now we have turned our cutting tool into some angle. How much angle we need, that should be calculated first. How much angle we need, that should be calculated first. After that, we are fixing our cutting tool in some inclination angle, right? Here, the angle which is needed, is equal to half of the calculated taper angle. In the previous method also, we learned that the inclination angle on the cutting tool should be half of the desired taper shape, half of the desired taper angle. Right? Here also, the taper angle is calculated first, and then the compound rest is equal to half of the calculated taper angle. First, we are calculating the taper angle. By that angle, we are taking that half of the taper angle. By that method, we are taking that half of the taper angle. So with that half of the taper angle, we are swiveled the cutting tool with that angle. Okay, due to hand feed, by this method, we are giving hand feed. Already we are observing figure. The productivity is low and poor surface finish. Here, this is the taper turning by compound rest method, right? After getting the desired angle, we are rotating our compound rest. We are swiveled our compound rest in the desired shape angle and giving the feed by this rotating this hand wheel. So it is moving in this direction. So how much this compound rest is moving up to some length, that much of length taper is only produced. After movement is reach its maximum position, the taper shape is also reached the end point. So that much of length taper only is produced. This is the drawback by this method. Okay. Before going to discussing about the taper angle calculation, once again you can recall this taper turning by compound rest method. Compound rest method, in that compound rest method, it is having some degrees on it. So that compound rest is swiveled on that desired angle because it is graduated with some degrees. So we are rotating compound rest with the desired angle. The desired angle can be calculated by using some formula, right? With that formula, we are calculating the taper angle. After getting that taper angle, we are taking half of the taper angle because the workpiece is rotated and the cutting tool is moving, so it is removing the material on both sides. That's why we are taking half of the taper angle. So we are getting the desired taper shape, right? So after doing forming tool method, the longer tapers cannot produce it by the forming tool method. For that reason, we are going to deal the compound rest method. But in compound rest method, the length is also a limitation. Well, how the length is limitation means here the compound rest is moving some distance only, right? So for that reason, here also the length is limited, but compared to forming tool method, the length is more compared to the forming tool method. In the degrees, are graduated and graduated to the compound rest. So with that degrees, we are rotating our compound rest, right? So it is the taper angle calculations, right? So let us take it is our workpiece up to here. This is our workpiece. We are observing this is already shaped workpiece, but just assume here our workpiece is here to here. It is having single diameter, that is D. Here we are observing that figure is already shaped, taper shaped workpiece. Here the major diameter d, capital D, minor diameter small d, but before doing this process it is having inclination, it is having only capital diameter d, right? So now we are going to produce the taper shape of this workpiece. Okay. Now what we are going to do is we are extending this shape to here to here. So these 2 points are meeting at some point, right? Here the total length, total angle is called 2 alpha. It is called as included angle. It means full taper angle, right? So D is the large diameter mm, yeah, small d is the smaller diameter, and capital L is the length of the taper. Now here 2 alpha means, so this side alpha and this side alpha, right? Here 2 alpha means here alpha and here alpha, right? So come to here and extending this, so it is alpha, here also alpha, same inclination. That's why here alpha, here also alpha, right? So is BC. Okay. So length of AB, how much? L. AB is equal to L. Now we are going to calculate the alpha. So alpha means we need this length BC. That length is coming from this total length is B, and this length is D. D, capital D minus small d gives the D minus D gives the this length and this length. D minus D gives the this length and this length, right? So D minus D by 2. So and here also D minus D by 2. So tan alpha equal to BC by AB. So D minus D by 2L. So D minus D by L, that is K. So tan alpha is equal to tan inverse. So we don't need this. D minus D by L is equal to K. So tan alpha equal to D minus D by 2L. Alpha equal to tan inverse D minus D by 2L. So that alpha is the desired angle we are using on the compound rest. We are doing with the compound rest, right? So some problem is there. Calculate the compound rest angle for turning short taper. One is 16. Let alpha be the desired angle at which the compound rest will be set. Tan alpha equal to 2 into 15. Alpha equal to D minus D. That nothing but 1. The length of this is 15 taper. So desired alpha is equal to 1.91 degrees. Now we are moving to the next process, next method, that is taper turning by taper attachment method. Right? The two methods are forming tool method and compound fuel based method. The third one is taper turning by taper attachment method. In this taper attachment method, we need some attachment. Taper, the lathe machine is having some attachment at the other end, at the opposite end to the tool post, at the opposite end to the tool post. That is, attachment is linked to the cross line. That attachment is linked to the cross line. Okay. So in this method, the workpiece is aligned to lathe axis. Work is aligned to the lathe axis, right? Before going to discussing about this method, what are the drawbacks of the previous methods? The first one is uh, length is the problem. It is having small length. We are producing small length tapers, right? In the next method also, compared to farming tool method, that compound swellness method also is having length of taper is the problem. But compared to farming tool method, compound method is used for some length of jobs. Now, for length of work, for lengthy jobs, we are going to produce the taper on the lengthy long jobs. For that reason, we need another method, that is taper turning, that is taper attachment method. In this method, the workpiece is aligned to the lathe axis and cutting tool is fed at an angle to axis of works by means of attachment. Cutting tool is fed at an angle to the axis of work by means of attachment. The attachment consists of bracket with graduated degrees guide bar. That cutting tool is fed at an angle to the axis of work by means of attachment. In the compound smooth rest method, the cutting tool is fed at an angle to the axis of work by swiveling the compound rest with the desired angle, right? Swiveling the compound rest with the desired angle, the cutting tool is fed against the workpiece with inclination angle. But in this method, the cutting tool is fed at an angle to the axis of work by means of some special attachment. That attachment consists of a bracket with a graduated degrees guide bar. That attachment, how it looks like, it is consists of a bracket and with a graduated degrees guide bar. So on that, it can be swiveled on either side of zero graduation. It can be swiveled on either side. It can be rotated on both sides. It can be swiveled, not rotated. It can be swiveled on either side of zero graduation, right? For using taper turning attachment, the cross slide where this attachment is fixed, right? Okay. For in this taper turning attachment, the cross slide is disconnected with cross feed screw. We're not giving any cross feeding by doing taper turning method. That's why that cross slide is disconnected with cross feed screw. What we are doing with cross feed screw, we are giving depth of cut, or we are doing facing operation. After doing facing operation, right? Next, our process is to produce a taper surface. For that reason, the cross slide is disconnected with the cross feed screw, and the rear end of cross slide, other end of the cross slide is attached to that guide bar. Already we learned that the guide bar is having a bracket with a graduated degrees. Okay, that attachment is having graduated degrees and graduated degrees and a bracket, right? So it can be used for turning external tapers. So after getting that attachment, we can make the angles on the cutting tool. So by that we are producing the tapers on the workpiece. Length of taper is limited to length of slide bar, right? Here also length is the problem, but how much length we are having that slide bar, that much of length of taper is produced on the workpiece. Okay. In this figure, we are observing that this is the attachment. It is having brackets and is a bar. It is having graduated degrees on that bar. So this entire attachment can be swiveled on either side. It can be swiveled on this side or it can be swiveled on this side. Okay. So this link is attached to this cross line. Understood? So this is the taper attachment. This entire thing is the taper attachment. Right? On the taper attachment, we are having this bar, and it can be swiveled on either sides. So here, observe here, this is our workpiece, and it is a tool post here. Tool post. Opposite this tool post, we are having this attachment, right? This is the bar. It is having degrees on this bar, right? It is linked with this bar. So we are swiveled this bar on with some desired angle for calculating. With the desired angle, it can be swiveled, right? So after giving the desired angle, we are moving our cutting tool parallel to this axis. We are not making any inclination by this cutting tool. Just we are attaching some taper attachment here. We are attaching some taper attachment, and we are giving our desired angle here only. After giving desired angle here, automatically the cutting tool is moving with that desired angle only. With that desired angle, it can produce the taper on the workpiece. So the length, how much? So here the attachment length is from here to here, here to here. So that much of length only we are producing the taper on the workpiece, because that cutting tool is moving on this bar with this inclination angle. So with this inclination angle only, up to here it is moving. So up to that only we are getting the taper shape, right? We have the taper turning, right? Taper attachment methods. So in this, we are learned that three methods, that is taper turning, a compound method, compound-based method, taper turn, taper attachment method. And another method is there, tailstock set over method, right? So these four methods we are producing tapers on the piece. Very steep taper on longer workpiece may be turned by the following method: taper attachment method, tailstock set over, compound-based, and not this taper attachment method, right? So after this, we are doing some video on these four methods. Then by that we can understand easily, right? So this is the compound method. See here, fixing our cutting tool with some inclination, right? This compound test and feeding in this direction. How can you calculate? So this is the actual workpiece to here, right? This is the half of taper angle. This one of the taper angle. Okay, we calculate tan alpha is equal to capital T. So this is the major diameter minus n minus length of major minus PL minus D by 2A, right? So this is half of the length. Is the length of the workpiece, right? That is the compound ratio. So after calculating this formula, we are getting the desired angle. With the desired angle, uh, we are swivel our cutting tool on the compound rest and moving our cutting tool to the desired. Right? Next, we are going to the taper turning the offsetting method. That is, this is the chuck, and we are fixing our workpiece with some inclination and set over. That means the tail stroke is not with the coinc the tail stroke is not coincide with this check, right? There is some offset in the activation. So this is the offset. This means here we are giving some offset. So what tail stroke is there. So here we are fixing our job and cutting to there. This offset is calculated by S is equal to length into conicity by Z. That means this is the length of the workpiece. This is the length. So after giving this offset, yes, we are giving feed into this workpiece. So cutting to is going in this direction. Okay, here also, and with the minus here by. So this is the conicity value. Dn minus dc by l equal nothing but here the conicity value. Right? We know already this conicity value. With that, we are calculating the offset. With that offset length, we are fixing our gauge star by this method. So after doing so, we are now angle into the cutting tool only. We are giving cutting tool is uh, parallel direction movement. Okay. So this is equal to L into dl minus dv by 2L. So the other method is taper turning by a form tool method. So we have already discussed that the taper turning the form tool is that is. So what are the shape we are going to produce on the workpiece? That shape is on the cutting tool. So that is the forming tool, right? So the workpiece is fixed on in the two centers. It is the chuck center and it is the tail stock center. The forming tool is having some inclination. What inclination? It is having the desired inclination, right? Desired length of inclination. With that desired length of inclination, we are having the desired taper shape. Desired taper shape. I'm already told that the drawback is here the width. How much width it is having? The table it is having some width. With that width only we are having this shape. That width only we are having this shape. Right? Up to here only we are having the taper shape. Beyond this, we are not getting because the width is limited to here only. Right? And this shape is reproduced on the workpiece. That's why it is called as a form tool. Forming tool. The last method is taper turning by taper attachment method. And we have discussed already that is here the workpiece is fixed. This is the center, this is the center, this is fixed to this two centers. Here the tool post and here the cross slide. It is the cross slide is attached to this guide rail, and this guide bar is having graduations on this. Here also it is having guide graduations. So this guide bar is swiveled on this guide block. What is the desired angle we need? We are swiveled this guide bar on this guide block, right? This guide bar is swiveled on this guide bar, right? So guide bar is swiveled. So after swiveling, we are moving our cutting tool in the parallel direction only. That is at this direction only. But it is automatically it is having some implication with this guide bar attachment. For that reason, we are having this direction, right? So after this animation, this the guide bar is swiveled in this direction. So it is attached with this translate particle, right? So guide bar is having this joint with the clamp. We can fix this clamp. So we are this is the fade. How we are doing the fade. So the particle is moving in this direction. Here the inclination. Here the length of the bar is limited to length of this. Length of the workpiece is limited to length of the bar. So this paper is bending on the workpiece. This much of paper is bending on the workpiece. This is a paper attachment. It is attached to the cross slab, right? And the guide bar is having